Welcome to Calc Chat 17. Today we're going to be talking about rates of change and how that affects particle motion. So the first thing we need to talk about is what actually particle motion is. So we're talking about, I like to think of a particle as a small ball, and we're talking about it moving along a straight line. So if I have a line that looks like this, 0 is this idea of my origin. So my particle moves along the line, and it either can go to the right or to the left. And so when I get over into these values, they're -1, -2, -3. And when I get over to these values, it's 1, 2, 3. So it's either moving in the positive direction or moving in the negative direction. And so we use what's called a position function to describe the nature of this particle. And so we normally see it as x of t or s of t, and x of t or s of t is generally measured in meters or yards or feet, and t is where that is equal to our time. So when we talk about the different ideas of particle motion, we can talk about instantaneous velocity. And so instantaneous velocity, that's the slope of the tangent line. That's just our derivative of the position function. So we usually say v of t, and that is equal to the derivative of our position function. Speed is our absolute value of velocity. So it's the absolute value of our, the derivative of our position function is the absolute value of our velocity. So velocity can be either positive or negative. Speed can only be positive. And acceleration, that's the derivative of our velocity function. So acceleration is how fast I'm speeding up. So generally, we measure speed and velocity in, let's say, meters per second, miles per hour. We would measure acceleration in meters per second squared, or miles per hour squared. So those are just kind of some examples of units. And then jerk, that is the derivative of our acceleration function. So this is the third derivative of our position function. And so jerk is like if you get into a car accident and you get hit from behind and your head jerks back into your seat. So that's kind of the idea of jerk, and this is generally measured in meters per second cubed. Another example would be miles per hour cubed. So jerk is kind of an even more rough motion than acceleration. So when we have this particle moving along the line, we can generally tell if it's speeding up or slowing down. So if my velocity is positive and my acceleration is positive, then the particle is speeding up. So its speed is increasing. If my velocity is negative and my acceleration is negative, then my particle is slowing down. Consequently, if my velocity is positive and acceleration is negative, the particle is slowing down. And if my velocity is negative, acceleration is positive, then it's also slowing down. So if my two signs are the same, it's speeding up. My two signs are different, it's slowing down. So this is an example of a graph of a particle's velocity. So we can see that v of t is on my y-axis, t is on my x-axis. So here I'm just kind of going to look at initially where does my function have a positive and negative velocity. And so I see that my function has a positive velocity, again, when it's above the y-axis. So this is our first derivative, so we're just looking at where our derivative is positive. So vt is positive from 0 to 2, and then from 6 to 8. And so my velocity is negative from 2 all the way to 6. Now, if I remember that acceleration is a derivative of velocity, when I look for acceleration on my graph, I'm actually going to be looking at the slope of velocity. Since acceleration is a derivative, when we look at acceleration, we look at the slope of velocity. So here I can see, I'm going to put acceleration in red. So here I can see my function is going down. So the slope of that line, even though my velocity is positive, my acceleration is negative. And again, I continue to go down. I have a negative acceleration. Now, all of a sudden at 4, I turn around and I have a positive acceleration. And then again, I have a positive acceleration. So I'm going to go ahead and write down my intervals. So for acceleration, I said it was negative from 0 to 2, and it was also negative from 2 to 4. My acceleration was positive from 4 to 6, and also 4 to 8. Or sorry, 6 to 8, not 4 to 8. There we go. So the reason I'm kind of splitting this up is because I see I really have 4 intervals that I'm looking at. So from 1 to 2, 2 to 4, 4 to 6, and 6 to 8. So from 1 to 2, my signs don't match up. So my velocity is positive, acceleration is 0. So I can say my particle is slowing down. From 0 to 2. So that's one of my intervals. And I said down here my velocity was negative. And it's also slowing down from 4 to 6. So these are the 2 places that my particle is slowing down. And then I see that from 2 to 4, I have both negatives. So my particle is speeding up from 2 to 4. And then if I go back up, I see I have a positive velocity, positive acceleration there as well. And so it's also speeding up from 6 to 8. So this graph, it gave us a lot of information about the velocity, and from the velocity, I could find information about the acceleration and tell whether or not my particle is speeding up or slowing down. So with particle motion, we have word problems. And so here are some kind of things to look out for. So if a problem has the word initially in it, we're looking for t equals 0. At rest, we're looking for where our velocity is equal to 0. At the origin, we're looking for where the position is 0. When I'm looking for velocity is positive, my particle is moving right. So this kind of goes back to our line. So when my particle moves right, it moves in the positive direction. When it moves left, it moves in the negative direction. So when velocity is negative, particle is moving to the left. Average velocity, that's the average rate of change. So that's the f of b minus f of a all over b minus a, but with our position function. Instantaneous velocity, that's our just regular velocity function. Positive acceleration, my velocity is increasing. I'm getting faster. And negative acceleration, my velocity is decreasing, and speed is the absolute value of velocity. So this is just kind of a quick reference for when we're doing word problems. So looking at this, it tells me a particle moves along a line so that its position is at any time is greater than or equal to 0 is given by the function s of t equals t minus 2 squared times t minus 4. S is measured in meters and t is measured in seconds. So I'm looking for the instantaneous velocity at any time t, so this tells me I'm looking for v of t. So I'm going to take my position function, take the derivative. So s of t equals t minus 2 squared times t minus 4. This is one that I need to use the product rule for. So this is my u, this is my v, and I also need to use the chain rule. So I'm going to take t minus 2 squared times the derivative of t minus 4 is just 1, plus t minus 4. The derivative of u is, I bring down the 2, t minus 2 to the 2 minus 1 is just 1 times 1. So this product rule and chain rule, and I'm going to get t minus 2 squared plus 2 t minus 2 t minus 4. And so another thing I'm going to do, because I'm looking ahead and I'm seeing that I need to find acceleration next, is I'm going to rewrite this velocity. So this is our velocity function. You can leave it like this. That's totally fine. But since I already looked ahead and I found that I needed to find the derivative again, I'm just going to simplify this. And so I kind of did this beforehand. You can check my math if you want. But when I multiply everything out and simplify this, you should get 3t squared minus 16t plus 20. So this is just the simplified version / I'll say foiled out. So I just foiled the velocity to get this. Either answer would work though. So now I look forward, I need to find the acceleration. So I know that the acceleration is equal to the derivative of my velocity. And so my velocity was 3t squared minus 16t plus 20. So my acceleration is 2 times 3 is 6. T to the 2 minus 1 is just t. And then minus 16. So this was just the derivative of my velocity. Now it's asking me when is the particle at rest. So at rest, if we remember, is when is my velocity 0. And so I'm going to take my velocity, which was 3t squared minus 16t plus 20. I'm going to set that equal to 0. So I want to try to factor this out. So I get 3 times 20 is 60. So I'm looking for what multiplies to 60 and adds to negative 16, which I should get negative 10 and negative 6. So I get 3t squared minus 10t minus 6t plus 20. This is all equal to 0 still. Again, this is just basic algebra, stuff we've already learned. So I'm going to take out a t, 3t minus 10 minus 2, 3t minus 10. So I should get t minus 2 and 3t minus 10. And you might use a box. That's fine as long as you get these two factors, whatever method you have to use. It's fine. So t minus 2 equals 0. 3t minus 10 equals 0. T equals 2, and I add 10. 3t equals 10. T equals 10 thirds. So this is where these 2 points are where my velocity is 0. That's where my particle is at rest. All right, so now I'm asked to describe the motion of the particle. So this is kind of dealing with velocity because I'm looking at where does my particle change directions. So I'm looking at where does my velocity change? Where does my velocity shift? From positive to negative. So I'm actually going to go ahead and make a sign chart. So again, my velocity, I'm going to keep my simplified version, 3t minus 10, t minus 2. My critical points, where it was at rest, so where it stopped, were 2 and 10 thirds. So I'm going to look what happens on either side and in between to get an idea of if it's moving right, left, what's going on. So let's pick 0. So at 0, if I plug in 0 for t, I get this is a negative. I get 3t minus 10 is a negative times another negative, so that's a positive. So this is where my function is moving right. So then at 2, it stops. My velocity is equal to 0. My particle stops. A number between 2 and 10 thirds could be 3. So 3 times 3 is 9 minus 10. That's a negative. Positive, so this is negative. So my function moves left. And then past 10 thirds, let's just say 4 is greater than 10/3. So I'm going to plug in 4. I get that this first is positive, second is positive, so this is positive, so my function is moving right. And so along a line, this is kind of what my particle is doing. So it starts at a point, and then from time 0 to 2, it moves right, and then it starts moving back left again, and then it starts moving right. So it's just kind of going back and forth, and then it keeps going right. And so the way we write this out in words is we just say that the particle starts at t equals 0, and it moves right until, whoops, what the heck, until t equals 2. Then the particle stops and moves left until 10/3. Sorry, t equals 10/3. I gotta specify. T equals 10/3. The particle stops again. And continues moving right. All right, so the main key things that we gotta have. I know a lot of you ask me, well, what do we need? So you need where it starts. You need that it moves right until a certain time, and then that it stops at that time. You need that it moves left at a certain time, means that stops again and continues to move right. So if you want to phrase this differently than I have, just make sure you have kind of those key components, that it starts at this time and moves right, and then it stops, and then it moves left, and then it stops, and then moves right again. As long as you have those kind of basic ideas, you should be good. So this was a really, really long video, but I want to thank you guys for watching. There's a lot, and we're going to do a lot, so please come to class with any questions that you have about particle motion, because this is going to kind of affect what we do for almost the rest of the year. So yeah, please come to class with any questions. Please like and subscribe, and thank you for watching.